Redis Enterprise is the database for the instant experience that powers any data model, any deployment option, and a multitude of use cases. See why more than 7,100 customers worldwide, including Microsoft, Staples, and Twitch, choose Redis Enterprise for their database needs. Visit redislabs.com/InfoQ.
If you're a regular listener of the podcast, you may remember back in September of last year, we did a show with Justin Cormack of Docker. The topic of that podcast was decomposing the modern operating system. On that podcast, we spent quite a bit of time talking about Cilium. If you didn't hear that podcast or you're new to the show, Cilium is an in-kernel high-performance service mesh that leverages eBPF. In bringing network and application layer security policies based on container and pod identity and comes in the form of a CNI plugin. It's often been called IP tables on steroids. Just last week, Cilium 1.6 was released. Today on the podcast, we're talking with Thomas Graf about Cilium, the 1.6 release, and the road ahead. Thomas is one of the maintainers of Cilium and a co-founder of Isovalent, the company behind it. My name is Wes Rice. I'm the co-host of the podcast. The InfoQ podcast is a weekly podcast with software thought leaders around topics that relate to architecture. If you like what you hear, check out QCon San Francisco. It's a software conference I chair in the Bay Area this November. Thanks for joining. Thomas, welcome to the podcast.
Thanks a lot for having me, Wes.
Cilium 1.6 was released, I think, last week. It's a pretty feature-packed release. It seems like it may be one of the largest releases of Cilium yet.
It's probably the largest release in terms of commits. It's probably like the 1.0 was another big release, but 1.6 is definitely the most feature-packed release yet.
What's driving that velocity of the number of commits?
Well, we have more and more people that are super excited about Cilium, and more people are actually writing code for it. So releases just keep getting better.
How large is the community around Cilium now?
So we're just above 100 total contributors, and we have roughly between 20 and 40 people contributing to each Cilium release.
That's pretty awesome. So for those who don't know or didn't catch the podcast before, what's kind of like the elevator pitch for Cilium?
Well, to keep it very simple, eBPF, or Cilium brings eBPF to the cloud native world. Cilium uses this fantastic new technology called eBPF and provides networking, security, some service mesh values, and things like load balancing, brings into a cloud native world, specifically Kubernetes. And one other kind of real value add that we provide, that we don't stop at just layer 3, layer 4. We actually go into layer 7, so we understand API calls, which is very, very kind of a normal thing if you're used to service mesh, but it's actually a completely new value prop if you're used to just pure networking.
How is Cilium both a service mesh and a network plugin? What's that relationship?
So we started out as a pure networking plugin. We used eBPF to do pure networking and load balancing. At the same time, we realized that just caring about port numbers is not sufficient from a security perspective. So very early on, we added the capability and said, we want to understand application protocols. So we want to be able to give the opportunity to say, yes, a service can talk on port 80 or port 443, but then we also wanted to go further and say, hey, I want to restrict this down and only allow an HTTP call get to /public, but not get to /private. Or if you have multiple microservices consuming a data store, we want to be able to restrict it down and restrict access to a certain table or to a certain key prefix and so on. So that's where we kind of share or have some overlap with service mesh projects.
Is that all done in kernel space, or do you work with Envoy, for example, to do kind of some of the layer 7 stuff?
So we do both. We don't actually care that much where it's done. What we care about is low overhead, the most efficient way. So in some ways, or in some situations, Envoy is the best way to go, and then we simply go to Envoy. We have a couple of optimizations on how we can make it more efficient, so we can actually bring Envoy into the picture more effectively, and sometimes we can remain entirely in kernel and without Envoy. For example, for our DNS-based policies, we're using core DNS Go code to actually do this. So we're picking the best places, and we're switching between user space and kernel space to find the most ideal solution that has the least overhead. So we're not necessarily promoting one model over the other, like always sidecar, always proxy, or always in kernel. We provide the flexibility to go either way.
Do you work with other proxies besides Envoy, or is Envoy the focus?
So Envoy is the focus in terms of how Cilium enforces HTTP policies. But if we look into our, what we call a sidecar acceleration technology, which improves the throughput and reduces the latency in a sidecar model, that actually applies not only to Envoy, but that also applies to Linkerd or HA proxy or any other proxy that runs on the same node. So some values, some features are Envoy specific, Envoy and Istio, and others are completely sidecar neutral.
So one of the first questions I get whenever I bring up, a platform or talk about anything new, someone always raises their hand and says, yeah, but who's using it? So Facebook is not using Cilium, are they? But what are some of the other stories of people that are using Cilium?
Correct. Yeah. Facebook is not using Cilium. Facebook is co-maintaining eBPF together with us. On the Cilium user side, our community has grown tremendously in the last 12 months. So we went 1.0 16 months ago, roughly. In the last 12 months, we've gained a ton of very, very interesting users. So we have users from Apple, Datadog, Adobe, Palantir, Bell, TFG, Overstock, Figo, MLB. Just join our Slack channel and look at who's there, and you will basically see how big our user community has grown to.
What does the release cycle look like with Cilium? Does it follow Kubernetes?
It pretty much follows Kubernetes. We try to release exactly the same time to make sure that we enable the latest and greatest Kubernetes version that just came out.
eBPF was originally early 2000s or so, I think the paper came out. Is it just the cloud native eBPF and cloud native? What's caused the kind of momentum today that kind of gave rise to Cilium?
So BPF in the beginning was very, very networking specific. That's why it's called Berkeley Packet Filter. It was meant to do filtering on data links. If you look at eBPF today, it has the same roots, but it has grown much further. It's now used for system call filtering. It's used for tracing, profiling, for a lot of different sandboxing mechanisms, right? So eBPF has grown to become much bigger than just having a networking scope. So at this point, it is a general purpose programming language to extend the Linux kernel.
Yeah, and just so people know, eBPF is a language that has kind of a just-in-time compiler that produces a binary.
Yeah, so the user basically writes BPF bytecode or uses a compiler to generate BPF bytecode, loads that into the Linux kernel. The Linux kernel will validate and verify that the bytecode is safe to run, then JIT compile it to whatever CPU you're running and then execute it natively. So that's a couple of the differences. BPF originally did not have a JIT compiler, did not have a verifier, and so on. So there's a tons of technical difference as well, but the overall big difference is that the scope has been extended very much.
Can you talk about an example use case that eBPF Cilium really excel at?
Yeah, there's several of them. One of them were an incredibly flexible networking solution, which means we can adjust to whatever needs our users have. So we not only serve needs for bare metal users, where a lot of people will do direct routing. We also have an actual VXLAN or Geneve-based overlay mode, which is sometimes applicable on cloud or multi-cloud types. Then we have integration into, let's say, cloud provider-specific networking, AWS, ENI, and so on. And all of this is because eBPF is flexible, is programmable. So we're not just mapping known existing Linux kernel networking constructs. We're creating new ones with eBPF. This flexibility is very, very unique and allows us to adjust to whatever needs our users have. Then from an actual overhead perspective, eBPF allows us to provide the most efficient implementation for what we need. A specific example here is Kubernetes services. The standard implementation is kubeproxy, which is IP tables based. By using eBPF, we're using very, very efficient hash tables instead of linear list of rules, which are many times better in terms of latency.
Yeah, there's the IP tables on steroids, right?
Yeah, exactly. Yeah.
So let's talk about specifically in the 1.6 release. I think you did some work in that space along with a few other things. I think 1.5 was all about scalability for Cilium running in clusters on a large number of nodes. What's the focus of 1.6?
So 1.6 was about policy scalability. So we basically had a huge push for scalability in 1.5 and 1.6. 1.5 was the scalability focus was on the non-security policy enforcement side. In 1.6, we made a giant leap forward in terms of allowing to do policy enforcement across many, many, many clusters. So Cilium has a multi-cluster feature built in, which allows to connect multiple Kubernetes clusters together and have them behave as if it was one big cluster in terms of networking behavior, and then define fine-grained policies that can scale across many, many 100,000 pods. So in order to do that, we optimized the control plane quite a bit to actually allow for that. 1.6 had a ton of other features as well. For example, KV store free operation, which was a big feature asked by users. We have been not slow, but we have been careful, but because we understood that by taking out the KV store component, we would struggle to scale a little bit. With 1.6, we found a solution that is the absolute ideal compromise. We are now fully backed by Kubernetes CRDs in terms of storing all the state, but then we can transparently and on the fly bring in a KV store to optimize the propagation of state. So that sounds a bit technical, but it basically means that we can benefit from the KV store scale without depending on it, which means the users, small scale users can run entirely Kubernetes CRD based. And as you scale up, you can basically bring in a KV store as needed to actually scale. That was a huge forward in terms of simplicity. Now it's deploying a single YAML file to deploy Cilium into your cluster. So, and then the next big feature was entire kubeproxy replacement. So we have been implementing Kubernetes services for a while, but only cluster IP, so only pod-to-pod load balancing. With 1.6, we're a full-blown kubeproxy replacement, which means you can run Cilium instead of running kubeproxy and have a completely IP tables-free Kubernetes cluster and have Cilium take care of cluster IP, node port, host port, and so on.
Let's talk about that for 1 second. When you say IP tables free, what do you mean by IP tables free?
So if you run kubeproxy in the default configuration, you will get an IP tables based implementation, which will install several IP tables rules for every service that you have deployed. Which means as your cluster scales up, each of your worker nodes we will have a list that gets longer and longer and longer. Eventually, there will be thousands and thousands of rules. And for every connection that is new, the entire list of rules, worst case, has to be looked for, right, to find the actual service entry. In the case of Cilium, you're using eBPF with very efficient per CPU hash tables to implement the same. So it's the same functionality, but a very efficient implementation, which means regardless of whether you're running one Kubernetes service or 1,000 or 5,000, you will have the same latency.
What about the socket-based load balancing? That's also something that I'm super curious about with 1.6.
This is another big feature that we're just getting started with. So at the beginning, we basically followed what every networking plugin would do, which is solve networking problems at the networking layer. So deal with network packets. So in the case of load balancing, what you do is you look at packets, and if a packet is going to a Kubernetes service IP, you look up what backend IPs this service IP maps to, and then you rewrite all IP addresses in every single packet. So if you have a TCP connection, every single packet in both the forward and the reverse direction, you will translate IP addresses. With socket-based load balancing, we're doing something very, very different. We're using eBPF to hook into the system call layer at the socket level. So the socket is what the application opens to open a TCP connection. And instead of doing network-based load balancing, we're basically translating the address within the system call, which means that for the entire duration of the TCP connection, no actual IP address translation will ever occur. The actual translation happens before the TCP connection even happens, which means that you can run as many services as you want. You will have a one-time cost that you pay at the connect system call time, and the rest of the connection will be completely overhead-free.
So this is completely below like consistent hashing, and that happens at one level, and below this, you're doing all the TCP routing or packet routing.
Yes, correct. Yes. And the reason why I'm saying we're just this is just a starting point. Pretty much all of the value that we've been creating so far with Cilium, from like multi-cluster, load balancing, policy enforcement, all of that will move to the socket layer because it's more efficient and it's more transparent, right? If a policy violation occurs on networking level, typically you drop the packet, which means that for an application developer, it will look like a timeout. If we're doing something like this at the socket layer, we can actually respond to the application with an error code, and we can say, hey, you're doing something that you're not allowed to do, which means that we will see a specific error message in your application logs. And similar for actual load balancing, we can tell the application that it did not succeed because there was no backend available, right? We're not just not translating the errors, we can tell why. And I think overall, this will be very beneficial, not just from an overhead perspective, but also from a transparency perspective, telling application developers what's exactly going on.
Yeah, that's really cool. I think there's also like generic CNI chaining. That one I don't understand. If Cilium is a plugin for CNI, why do we want to chain others?
That's a very good question. So CNI is basically just a networking piece, right? Which means the CNI spec basically says, give networking to this pod. Cilium does much more than this, right? Cilium does load balancing, Cilium does network policy, Cilium does multi-cluster, Cilium can do transparent encryption, and so on. And in several cases, for example, managed Kubernetes, cloud providers have their own CNI plugins which work with their actual network hardware well. In those scenarios, we can run on top of an existing CNI and provide all the other values that are not networking specific. So you can, for example, run the AWS VPC CNI plugin, and then on top of that, run Cilium to do multi-cluster with a GKE cluster, or do transparent encryption between an EKS cluster and a GKE cluster, and so on. So we're decoupling networking and policy and load balancing and all the other non-CNI values.
What else is in the release that people should be aware of?
I think, as we mentioned, the policy scalability improvements will be very big. Obviously, there's a ton of fixes. We have a native AWS mode at this point, which we work together with Palantir. which will be very, very interesting to our users on AWS. What's new here is that instead of using a per node approach of doing AWS ENI allocation as done natively by the AWS ENI plugin, we're using an operator-based approach, which scales much better, in particular if you're using auto-scaling and you're running several hundred nodes. So users running high scale on AWS should definitely have a look at our 1.6 release blog and kind of dig into the AWS ENI.
What does high scale mean?
So high scale could be a several hundred nodes where you add 500 nodes in 5 minutes, or it could mean running several thousand nodes. If you're like 100 or 200 nodes, that's not high scale yet from a perspective. So high scale means if you're running at the scale where you're running into rate limiting with, for example, with different AWS APIs, that would be high scale.
Yeah, nice. I want to move into and talk a bit about security. This is a core security component now that's part of our infrastructure. So I want to talk about things like Spectre from last year and how it was dealt with, and then maybe some of the eBPF security bugs that were recent and how that affects Cilium and how that affects users doing it. But before we go into that, one of the things that I really like Cilium for is what you just mentioned. I want to talk a bit about it. And that was transparent encryption and being able to like encrypt on the wire east to west, north to south between services with Cilium. It wasn't part of this release, it was previous. But can you talk a bit about that and what that means to a service mesh that's in kernel?
Absolutely. So encryption is coming up as a requirement more and more frequently, whether it's GDPR or some other compliance requirements where the requirement is that all the traffic needs to be encrypted. Now you have a couple of options out there. Either you can do this on your VPN network level. That's how it was done in the past. Or you can go the other extreme and say, I want to enable NTLS, mutual TLS, across my entire service fleet and actually enable all my applications to be MTLS enabled. If you don't want to do that, you can say, I want to run a service mesh and have the service mesh on the behalf of the application do mutual TLS. What we're providing is something similar. We're also providing transparent encryption, but we're using in-kernel encryption technology. Right now, that's using IPsec, and in the future, we'll also provide this using WireGuard. This has a couple of advantages. It means that we can do this completely transparently, regardless of the actual protocol that the application is using. So it's not limited to IPv4 or TCP or anything like this. All traffic between any pod in the cluster, between any node to pod, between any worker node will be encrypted, and we can guarantee it's on kernel level. It's completely transparent to the application. Plus, we can also easily integrate into VMs. So we have a mode where Cilium can run on a VM and basically hook a VM that's not running containers, just a pure VM, and hook that into this encrypted mesh as well. And because it's IPsec, you can obviously integrate any sort of IPsec concentrator as well.
That's awesome, but that does bring questions about, observability. If everything's encrypted, how do you ever know what's going on? How does Cilium address that?
Yeah, so because Cilium is doing the encryption, we can see everything before we actually encrypt it. So Cilium has extensive APIs where you can get everything from metrics to flow data on what's actually going on. So you're not losing any visibility, but we guarantee that everything is encrypted on the wire. So like if you have a requirement that you want to run a zero trust environment where you don't want to trust your network, we can encrypt everything that is leaving a node.
That's awesome. That's one of the first features that really kind of blew me away about Cilium. All right, so the next piece that I want to go to, as I mentioned before, is security. And this is a core, like I said before, it's kind of IP tables on steroids. This is our core networking, our core security for what we're doing with services. So people will have a lot of security questions. Last year, Spectre Meltdown came out, and Spectre had an ability that could be able to execute eBPF and run to get things to just-in-time compile and actually expose and leak some kernel memory. That was eBPF and kind of a side attack. But how does Cilium prevent and protect against things like that from happening?
So first of all, I think it's incredibly important that we pay the most attention we can possibly can to the security of eBPF. And I think that's actually what's happening. That's why some flaws were found. eBPF is, for example, is being used in Facebook since May 2017 in all production environments. So it's not just us, it's like us, Netflix, Google, and Reddit, others that kind of have interest in eBPF being production ready and secure. So there's a lot of people already looking to make sure that it's absolutely secure. The reason to talk specifically about Spectre Meltdown, first of all, for any of the flaws that were found, it requires that you're able to inject BPF bytecode. By default, you need privileges to do so. So the flaws that were found would only apply if you allow unprivileged processes to load BPF. In our documentation, and I think in any Linux distribution that you will find that this is disabled, and it is recommended to keep it disabled. Right? So that's kind of the first step. For Spectre Meltdown, it was very appealing to use eBPF to validate and to exploit these attacks because with BPF, you can load bytecode in a very specific order, right? You can literally exploit how the CPU executes it afterwards. So it was less of a BPF specific attack or like a BPF specific bug, but BPF made it very simple to actually exploit it. It was mitigated using several Linux kernel patches that would both prevent attack and also make sure that we're not losing all of the performance, because obviously a lot of the Spectre Meltdown mitigations have caused quite a severe performance slowdown. In terms of what Cilium can do, if you're running BPF in unprivileged mode, we are warning that you're doing so, for example. But like none of the attacks were specifically Cilium related.
There was a policy bypass, CVE 2019-13-119, from a couple months ago that was on eBPF. But what I thought we might do is kind of just talk about what that looked like to someone who was running Cilium before that was announced, how it was raised, and what kind of processes are in place to make sure that people are protected as quickly as possible. So when was it raised, and what's the kind of the process that you all go through?
So that specific issue that you're referring to was actually 3 CNI plugins were affected by that. That was a Cilium bug, a pure Cilium bug that in combination with Kubernetes. So that was not eBPF specific. So we'll follow best practices in terms of security. Like that issue was found by a community member. A community member used our security mailing list to disclose the bug to us. We contacted other vendors, other CNI or other CNI projects, informed them. We defined an embargo period, made sure that everybody had time to fix it. We reserved the CV numbers, then actually disclosed the bug and published the fixes. So we're using best practices in terms of security. We're making sure that our community knows how to disclose bugs.
And what was the timeline from when it was first brought to your attention through when you notified the community?
I think it was about 2 weeks. I think 2 or 3 weeks is what the embargo time we actually completed. I think we would have been able to fix it within 2 or 3 days. The bug fix was really simple, but it's really important that everybody has time to fix bugs correctly. Worst case is always you publish a bug fix, but then the bug fix is not really effective. At that point, everybody knows how to exploit it, but the bug fix is not actually real.
Then when you published the bug fix, was that just for the current release? How far back did you go?
So we provide backports 3 releases back, which means for 9 months. So we have obviously released that bug fix immediately for all our minor releases that we support. So we allow users to have, not just for security bug fixes, but for bug fixes in general, have 9 months right now. As part of our open source offering, we have a commercial offering that actually extends this further. But our open source offering is basically that you have 9 months of stable releases.
Well, let's talk about that. You mentioned you have a commercial version, you have a open source. Is the commercial the same as upstream? What's all that look like?
It's entirely the same as upstream, so there's no open core modeling anyway. The difference is additional management tooling on top and difference in support. Right? So we actually provide more like backports for longer, for example. Like a commercial customer of ours could say, I actually want to use an old release longer. Can you maintain this for us? And then yes, we will do this.
Coming to the end here, what's next for Cilium? What's in the 117 release and what's coming up?
Yeah, so I think we'll definitely see more on the socket level. So we'll keep kind of raising up the stack into the socket level more. We're getting pushed harder and harder to take on more of the service mesh values. We're a bit careful because we're not a full-blown service mesh by no means. We do provide some values which overlap with service mesh. Let's say authorization, like layer 7 aware authorization, encryption. But for example, we're not doing any layer 7 based load balancing right now, and we're not planning to do so. But we're getting pushed into a direction where users are saying, I need 80% of the service mesh value. Let's say I need some of the visibility transparently, but I want it very, very efficiently. Or I want to run this across 20,000 nodes. Help us do transparent encryption across 20,000 nodes. Or help us do extensive load balancing, not L7, but like with actual multi-cluster array logic. Help us do that at scale. And that's where we are really, really good at. Like another focus that we'll continue to kind of push forward on is security. So right now, if you look at kind of Kubernetes security, you have runtime security where you care about like system calls or like actual container image scanning. And then you have network security, which is all about the networking layer. And as far as networking is concerned, you basically have the granularity of a pod, which means this pod can do this pod can do that. But if you look at what the pod is today, it's actually much more than just an app. It's usually an app and then a couple of sidecars, maybe an init container. if you define and if you want to have fine-grained security policies, you need to understand what's going in that pod. You may even want to be able to restrict what's going in that pod itself. So like if the sidecar is talking to the pod, is that allowed or is that not allowed? Should the application itself even be allowed to talk outside, or does it always have to go through the sidecar? So understanding what's going on in the pod, like having process level or process aware understanding, that will be one focus that we will push forward on.
And how is that actually controlled and configured by an application developer? So for me as an app developer, is this something that I'm configuring in YAMLs and CRDs that I'm actually setting up? What does it look like for me to be able to say my Redis container can only talk internal to a pod?
Yeah, so it would be very similar to what we do right now, a YAML file. And instead of pod labels, you would also, for example, be able to define a container name. If a pod manifests, you have stable container names in there. So that will become part of what you allow and what you don't allow.
One of the things that you just said when you were talking there is what Cilium does really well at and what it doesn't do so well at. One of the things you mentioned was the layer 7 load balancing. But I think that's really where you partner with things like Envoy and Istio to be able to achieve that. So Cilium works well with other service meshes. It just does that in-kernel kind of service mesh type stuff that they can't do. Is that accurate?
Absolutely. Like we're not competing or we're not trying to replace service mesh. I don't think that service mesh is always the answer for everything right now. I think we 100% agree with the shift that service mesh is bringing, which is let's go to layer 7. Let's bring application aware context into everything. Where we might disagree is that like the sidecar might not always be the answer. In some cases, absolutely, yes. In other cases, hey, if I only need transparent encryption and load balancing, maybe you don't need a full-blown sidecar. But we do have full Istio integration, which means you can choose to define Cilium layer 7 policies and have them enforced via an Istio managed pilot or an Istio managed Envoy instance. Or you can use Cilium to accelerate your Istio usage, right? You can use Cilium's service mesh acceleration, run your Istio or your Linkerd service mesh, and use Cilium to reduce some of the latency that was added by the socket or by the proxy-based sidecar model.
All right. Well, Thomas, thanks for joining us on the InfoQ podcast.